Welcome. In today's lesson, we're going to go over the new Java 9 JShell environment. It's a new shell script provided with Java 9 for us to do some actual real-time Java coding / testing of our ideas in our code. This is going to be a full interactive demo, so I'm going to cover the highlights of JShell, and then I'm going to keep jumping back and forth between the slides and the actual JShell environment so that we can get a real good example of how to use JShell. So today we're going to cover what JShell is. We're going to look at the types of components that you can use with JShell. We've got snippets, the types of commands you can use with JShell, how to edit in JShell, how to pull in external code so we can use Jigsaw on some of the module pieces that are new with Java 9. We also are going to look at the feedback modes. Those are kind of the echoes that come from when you run your little shell scripts. And we're going to look at how to save our scripts and load our scripts. In case we come up with a cool little script we like, we can export it and then copy and paste it into our actual projects. So what is JShell? Well, it's an interactive tool for learning and prototyping Java code. It is essentially kind of like a command line or like any other little shell environment like terminal, except it's specific to Java. So it's a read, evaluate, print loop, which evaluates your declarations, your statements, your expressions, and basically runs them real time. So you see all the results immediately. And it is a command line tool, so you do need to download the JDK and run this in Windows Command or Terminal, or from a terminal command on Mac or Linux. Well, why do we want to use JShell? Well, if you're running into some problems with your code and you want to just quickly go out and prototype or kind of type out the commands and play around with it, you can do it real quickly, real runtime. Whereas if you're in your IDE and you're typing stuff in, you then have to compile it, then you have to run it, and then you have to debug it. Whereas with JShell, you just literally start typing and you start to see the results immediately. And you can stack your shell commands on top of one another. So you can declare variables, you can declare methods, you can call methods, you can create classes, you can import classes, and so forth. And it's all real time. So if it breaks, you see it break, and you can try to figure out how to fix it right there. Once you fix it, you then copy it and paste it back into your project. You can test individual statements, like I said. You can experiment with unfamiliar APIs within the JShell session. You can also play around with some of the Jigsaw pieces with the modules of importing module path, sharing packages that you want within your projects. What JShell isn't, it is not an IDE. It is great for prototyping, great for testing things out, but it's really not meant to replace the traditional IDEs or development tools that we currently have. It's just something we have to, it's just another tool in our bucket to help make our coding life easier, help us debug things faster. So again, as you develop your program, you can paste the code into JShell, try it out, or copy it from JShell and paste it back into your editor or IDE once it works. The other cool thing with JShell is if you don't like working at the command line, you can actually export the code real time to like Notepad or an editor, make the changes there, save them, and they will go right back into JShell real time. So if you can't handle the command line stuff, you can actually still interact with an editor of your choice. So how do we use JShell? Well, first you have to install JDK 9. Once it's installed, you go out to the command line path and you type JShell. If you don't have your class path set up correctly, it won't find it, so you will have to make sure your Java home path is defined correctly in Windows, Linux, and Mac. If you want to get some messaging with your JShell as you type it, if you want to get feedback, all you have to do is add -v as one of the attributes, and then it will give you the verbose mode will be enabled. And then to exit JShell, it's just like the MySQL shell. You type exit or quit in MySQL. But here, you just do the /exit. All commands, once you're in the JShell editor, will start with the /, and then the command will follow after that. So the first thing we're going to talk about with JShell are snippets. So JShell accepts Java statements, variable declarations, methods and class definitions, imports, and expressions. So these pieces of code are referred to as snippets. So let's jump out real quick here and we'll take a look at an actual JShell environment. So I've done this in Windows. I have my command prompt. I am in my JDK bin directory, and this is where JShell lives. So you just type JShell. If you notice, I did not put the -v, so it's going to balk at, it won't give me all the wonderful verbose comments I want. So as soon as it starts, it takes it a second. I'm going to exit real quick, and I'm going to turn verbose on. As you can see, it does take it a minute to spin up. That's because it essentially is loading a Java virtual machine in memory and also enabling the loop for the JShell console. So we've now started JShell. Let's start by typing in our first statement. So let's declare a variable. So let's do string text equals hello. Text hello created. So we've now created a variable text and it's type string. So this is what verbose turns on. So it turns on this little feedback that we can get. Now we can turn that off with a couple other commands, which I'll talk about those later. But for now, we're going to keep the verbose on so we actually can get some feedback. The verbose messages start with a vertical bar. So in this example, both the name and the type of the created variable are shown. Also note that terminating semicolons are automatically added to the end of your code snippet if you don't enter it. So the string text hello works, and it would also work if I did put the semicolon at the end. The other thing is, this is in memory. So string text hello is there, and by retyping string text equals hello, I've essentially modified the existing variable that we defined. Let's look at what happens when we type in a snippet that does not have a named variable. So let me just type in an expression, 40 plus 2. 42. But it did declare a variable for us. So it created what is called a scratch variable that is prefixed with the $, and it's given a number. So it's essentially going to define the variable in the steps where it's at. So right now, we've declared hello.
Sorry to interrupt this, but it's sort of out of curiosity. So if you do I assume if you do like a system.out.println $3, then you'll get 42, correct?
Yes.
What happens if you do a system.out.println $2?
I think we'll get hello.
I'm sorry if I'm jumping ahead, but this is just, it's sort of interesting as to what it's...
Okay.
Oh, okay, so it hasn't said that. Okay, sorry, my curiosity got to me and I didn't have it in front, so...
Okay, and we'll get to that in a minute. There you go.
There we go. Okay.
Yeah, and actually, towards the end of this, I'll actually show you how you can essentially remove the need for system.out, and then you can get away with just typing print line, print f, print whatever, so you can actually remove the prefix of system.out, which makes this even more powerful because it's real quick to just pop through this stuff. All right, so when an expression is entered that does not have a named variable, a scratch variable is created, as we saw, so that the value can be referenced later, which we just did with the system.out print line. This also applies to method calls that return a value. So if I created a method here, let's just call it string echo, and it will take a string, and we'll just call the string text, and I'll make it simple, string asks. Now, if I hit enter, you notice it gives us the ... greater than. Well, that's basically telling you that you have not closed your expression yet. So you're still adding to your method or whatever the expression is that you are defining. So we're going to return S, still going. Now, if I put a close bracket there, it's now created the method. So it knows when you start and stop a script. All right, so now we have echo. So if I just do echo hello, now this is being returned a string, so, but we're not assigning the return to anything. But what the JShell does is it automatically assigns it to the scratch variables. And again, if we were to go back up, oh, by the way, up and down, just like in terminals, you can spin through your history. All right, now I kind of jumped ahead a little bit when I redid the hello, but snippets also have something called changing definitions. So once you've defined something like echo, you can go back and make a change. So as you experiment with your code, you might find that definition or variable, method, or class isn't doing exactly what you want it to do. So the definition is easily changed by entering a new one, which overwrites the previous definition. So let's change our echo method to append the string world to the end of our string. So if I just go up, and I'll kind of cheat here. So we'll take our string echo string, we'll do return s plus world, space, and we'll just add an exclamation point for the hell of it. Oops. Well, in this particular case, so when we're inside of our brackets, we actually have to include our semicolon. So the only time the semicolon is not necessary is when it's a one-liner. So here, when we're inside of a method, you have to use your semicolons. But if you're just doing a single expression, the semicolon is not required. So, in this case, try that. Yeah. So now it says we've updated our overwritten method echo string. So we've modified our method. So this is the predefined one that we had initially created. You can also change the definitions in incompatible ways. So the following example will show us what happens when you change a variable from an int to a string. So if I were to do int x equals 42, and I'm picking on 42 because that's the answer to life, the universe, and everything in the world of Douglas Adams and the Hitchhiker's Guide to the Galaxy. So if you see 42 everywhere, that's where it comes from. Big Douglas Adams fan. All right, so we've defined x as an int. But now, what if I do string x? All right, so we've replaced the variable x as a string, but we've also overwritten its value, so now it's null. So you have to be careful of this if you've defined your variable and you're using it as a global variable or it's a class variable amongst other methods. And that leads us into the next part of snippets, which are forward references. JShell accepts method definitions that reference methods, variables, or classes that aren't yet defined. So this is done to support exploratory programming, and because of some forms of programming require it. So as we write our class, we may create methods that call other methods that we just haven't created yet. So it lets us do that, except if you try to run the method before you declare all the pieces, things will break. So let's start out. I like math, so we'll do double hypotenuse, double A, double B. And we want to calculate the hypotenuse of a triangle. So we want to return math dot square root. We're going to call a method called square that will essentially double side A by itself and side B by itself, or a number by itself essentially. We've now created the method hypotenuse. It takes 2 doubles. However, it cannot be referenced until class double A and method square double are declared. So I can try to call it. Okay, that's weird. It should be giving me a different message than that, but we'll continue on. So what we need to add, so the missing piece was that square. So we need to add squares. Editor. All right, so we've now created method square double. Method hypotenuse double double. Okay. Now, if I call hypotenuse, there it goes. Okay. Wondered why it was giving me fits before. So, just like terminal, you can do abbreviations and hit tab, and it will auto-populate. And now I can do 2D, 3D, and boom. So now it's given me the hypotenuse of our triangle. And it's because I did not assign it to anything, it went ahead and created a scratch variable for it. Now we've called the hypotenuse and we've gotten our results. Now, what happens when we get an exception? So exceptions also happen in JShell, and there's a couple different ways you can handle it. So in an exception backtrace, the feedback identifies the snippet and the location within the snippet where the exception occurred. So if you get a runtime exception, you're going to get the location within the code entered into JShell is displayed as an ID, pound ID, and the line number. So it's going to give you the script ID and the line number of that script, where the snippet ID is the number displayed by the list command, and the line number is the line number within the snippet. So let's create a simple division by zero example that should throw a JavaOne arithmetic exception. So we'll do int divide in x in y turn x y close. So we've created a new method divide. I'll divide and 2, 0. And we get an arithmetic exception thrown by 0. So it's saying our script ID is 15, line 2 is where the error happened, and the call was 16 and 1, which was this guy here. So if I do list, so 16 was where the script that called it caused the exception, but the exception was triggered right here by the return XY. So that's 15, line 2. And finally, the shell also allows the use of tabs for completion of the snippet. So if we just started typing SY and hit tab, it should bring up a list of SY. It'll bring up a list of available code snippets to choose from. So if there's only one, it will use that one. If no results, then nothing will happen. So if like when I was doing lowercase sy, it didn't find anything. If I did uppercase sy, it gave me the 3 available classes: system, synchronous queue, and sync failed exception. So next, we have commands. So we just showed you the list command, but JShell commands get entered into JShell. They're used to control the environment and display information. All the commands are start with leading /. All the available commands here, we have list, edit, drop, save, open, bars, method, etc. We'll go through all those in a minute in the shell. And they can also be abbreviated. So if we just have one word that starts with list, so we have L, we can just do /L and it will know to use list. Now with edit and exist, we can't use E, we have to actually do the second letter. So you can do ED for edit, EX for exit, and EN for environment. And the rest are pretty much okay except for history and help, so you'd have to do /HI or /HE. Or with the exception, with the help, you can also do /, which is the traditional help. The last one got cut off a little bit, but there's also a /! But I'll show you how you can actually see all those in this minute. So if you actually just do / and hit tab, oops, let me do that again, /tab, it gives you all your list of commands. So you have !, etc. If you hit tab again, you now get the definition for each of those commands to tell you what they do. Let's start with the first one. So we'll do /list. So that just gives us, it shows us the source of snippets prefaced with the snippet ID. So we can do, and if you just do list, it gives you the abbreviated list. So you're only going to get the commands that were actually physically typed. If you do list all, you'll also get everything else in between. So it will give you all, so if you have duplicates, it will give you duplicates. Otherwise, it will limit it to the last one that you did. And it also includes all your imports, all your voids. So it basically gives you everything that's currently in memory. We can do /edit, and this will allow us to edit a snippet or snippet of source in an external editor. So the editor is used to set, you can set the editor by using /set and the editor name. No editor has been set, a simple editor will be launched. So if we just do ed, and let's see, we'll take 13, and it opened up the JShell edit pad. Now, and then in here, you can make some changes to this. So you can do side A, B, A, B, and you can cancel, exit, or accept. And if you accept, 13 has just been modified, and we exit out. And now if I do list, and 13 is going to be there's 13. Oh, here it is. And it puts it back in as a new entry. So when it comes back, it puts it back in as a new, basically as if you retyped it. So it overrode your previous command. You can drop it. So if you want to take it out of memory, you can do drop. 17. Okay, boom. It's now gone. There. It's actually gone. You can do list all to see it, but drop just makes it inactive, which is why you have to do list all to see it. If you want to save it out to a file, you can do save, and then you would have to actually put in your actual path name. And in my particular case, it's going to be C, user. Sorry. And we'll say test JavaShell. And it saved it out to our file. We go out and look at C, users, ID user. There's our test JavaShell. And if we wanted to load one, my other one is mysnippets.js. Do /open. And when it loads it, it also tries to run it. So it's essentially compiling it as it's loading it. And then if you want to see what variables are in memory or that have been defined, you can type /vars. There's all of our variable declarations. You want to see methods. There's all of our methods that we have defined. We have types. I have no types currently defined. Any imports I have defined. There's all the imports. If we wanted to exit, says goodbye, kicks us out, go back in. Now this next one, once it lets us back in, is the environment. Now, so it shows the evaluation context displayed as context options. So you can set your environment variables with env. Let me pull up. So it's got the 4 types. So you can add exports, add modules. You can set the class path, or you can set the module path. These are all the same pieces we've talked about before with Jigsaw, with the environment file that you define. The other thing, though, is these can also all be passed in at the command line with JShell. So I can actually do JShell-add exports, add the exports, add modules, add modules. So all these can be either set as the environment, or they can be set as attributes of the command line when you actually call it. Then if you hit tab one more time, and then here's a more detailed description of environment. So viewer change evaluation context. Again, you can set the path, module path. And then once it's finished, you can do /reload quiet, and it will reload it without resetting everything. I want to do the environment, so let's do environment. And it's going to fail because I don't have a com.examples module. If I did, it would have pulled it in on the restart, and it would say, hey, we found it. But it couldn't find it in this particular time, so we got to find exception error. But this is a very cool way of testing your Jigsaw to make sure that you have all the module pieces defined correctly. This is a great real-time way of doing it without having to constantly go back and forth and restarting your environment. So we've got reset. Resets the state. Basically clears everything you have. So now if I type list, nothing's there. So basically we now have a fresh slate. We can do /reload. So it's restarting and restoring state. So if you had anything stored in your state, it would have brought it back in once you reloaded it, and we don't. History, pretty much just like terminal history or any bash history. It just gives you all the commands you've typed since you've been in the shell, or since the last time it was reloaded. /debug, you can turn on the debugger. There wasn't a lot of information on this yet, so I don't think they're really sure how they want to use it. I think initially it's going to give you a lot of verbose, maybe a little more messaging when you actually get a runtime exception. But for now, I couldn't find a lot of documentation on it, so just know it's there. Maybe in a future release there'll be more information on it. You can do /help. Boom, there's more information on all the commands. You can do question mark and get the exact same thing. Set is something else. So set lets you set the JShell configuration information. Now this includes the external editor to use, the startup definition to use, a new feedback mode, the command prompt. You can reset what your prompt looks like. You can change the feedback mode to use or format of output. So for example, if we set feedback normal, we now lose the verbose. Or I can also set my editor to Notepad. Now, do /edit, now we got 1. So now, edit 1. Oh. From Notepad, create processor, cannot find the file specified. Okay. Let me give an actual command. Use string echo. String X. Case sensitive. Now we have it as number 3. Okay, so it doesn't like, oh, ha, Notepad. Yeah, Notepad's not going to work. Notepad, there we go. And now you see we actually open in Notepad, not that default editor that he had. All right, so there's that. And then if we do /! that will essentially rerun the last scriptlet that you wrote. So next, we have shell editing. So shell editing is supported for fully editing the current line or accessing the history, as you've seen me do it currently. There are other things you can navigate the input line, so you can use the control key, you can use the meta key. If you don't have a meta key, then the alt key is used for the mapping. Some of the typical commands are straightforward. So return enters the current line. A left arrow moves back and forth one character. Right arrow, up arrow lets you go through history. Down arrow goes through history. Control A takes you to the beginning of the line. Control E takes you to the end of the line. So Alt B moves backwards one word, and then Alt F moves forward one word. Some other keys are used to modify the line input. So delete deletes the character at or after the cursor, backspace, typical. But then there's another one here which you have Control K, which deletes text from the cursor to the end of the line. That's kind of cool. So okay, instead of returning X, I want to return X plus world. Cool, that was easy. Now if I do Control D, sorry, Alt D, deletes the text from the cursor to the end of the word. So it just deletes like the delete key. Oh wait, that was the wrong one. Help if I hold the right key. So in this case it'll be Alt D. So it drops the last part of the word. So it doesn't delete all the way to the end of the line, which Control K does. Alt D just deletes to the end of the word. Control W deletes the text from the cursor to the previous white space. So it takes us all the way back. And then Control Y, paste the most recently deleted text into the line. So then you have the Alt Y, Control Y, Alt Y cycles through previously deleted text. You can also search and create macros in JShell. For those, you do Control R. Let's see, search. Hit Control R, here we go. And I'll look for return. It will automatically start jumping to where it is I'm looking for. So Control R, so say I'm looking for string. Oh, I found that one. Okay, so if I hit Control R, string, well, that's not the one I want. Say Control R, Control S. Let me search through history. If you want to declare a macro, you can do Control X, which I haven't had much luck with the macros. It may be a feature that they're not fully utilizing yet, but it is there. So you do Control X, and you start with the parenthesis, type in your definition, and then Control X again, and you put a close parenthesis around it. And then to execute the macro is Control plus X plus the macro name. shells. Next, we have external code. So external classes are accessed from a JShell session through the class path. So again, this is actually really getting back into the whole jigsaw, the module definitions pieces. So if we go look at the actual code, so if we do /env again, we can add exports, add modules, class path, and module, or you could actually do these parameters from within the JShell. So again, it would look something like environment, class path, and you could do an example, class path, file not found, but if it did find it, it would include it. Or you could actually do it from JShell. You could do JShell-class path and type in the same thing. After you set your class path directories, you can then import them into your package so you can have access to them. So then you could do like import com.example.code and say I want to get everything in the library. I would do something like that. So right now it doesn't exist because the package doesn't exist. Feedback modes. Feedback modes help you determine the fonts, the feedbacks, and other interactions with the shell. So when we started out, we were verbose, so we're getting a lot of information when we typed in at our prompt. So every time we hit enter, we will get some feedback from the JShell telling us what we did. There are predefined modes with different levels of feedback. We have verbose, normal, concise, silent. Verbose we've been using. That gives us 4 different values. So verbose essentially returns the name value pair and the description of what you did. It also provides feedback for declarations of methods, classes, enumerations, interfaces, and annotations. It also changes to other snippets other than the current snippets are shown. So again, like if we were to make a change or define a class that calls another class, it will tell us, hey, this can't be run until you define the other piece, and then when you add the other piece, it will say, okay, we've gone back and we've updated all the pieces and confirmed everything works. It also gives you feedback to tell you if it was successful or not, and it indicates the prompt that is to be used, which will be a new line in the JShell. Normal just returns a name value pair, does not return the description, also gives you the feedback for the declarations or methods, classes, enumerations, and so forth. It gives you the feedback if indicating success, and it also returns the same prompt of new line in JShell. Concise is name value pair only for expressions, and it indicates that the prompt to be used is just JShell, so it does not give you a new line in between your expression and the response. And silent indicates that the prompt should be used is just a dash arrow and nothing gets printed out. It basically says, hey, you ran something and here's your feedback. So if we go look at that, do set feedback silent, I get the little dash arrow. If I change that to concise, I get JShell. If I change that to normal, I get a feedback mode normal, and I get a space in between. And if I go back to verbose, I get the same particular feedback this time, but if I do int x equals 0, create variable x, and I get the name value pair there. So if I change this back to normal, whoops, back to normal, there I get the x is set to 0, but I don't get the description of what happened. Lastly, we have scripts. So a JShell script is a sequence of snippets and JShell commands in a file, one snippet or command per line, not per file. Scriptlets can be a local file or one of the following predefined scripts. So this is where I was talking before, where we could actually set up a printing script to take away the prefix of system.out. So let's go look at that. So if I were to, so let me break them down real quick. So default includes commonly needed import declarations like the java.lang, java.util. This script is used if no other startup script is provided. Printing defines JShell methods that redirect to print, printline, printf methods in the print stream. Java SE imports the core Java SE API defined by the java.se module, which causes a notable delay in starting JShell due to the number of packages. So let's remove that the need for the prefix of the system.out. So we're going to use the predefined printing script to access the print, printline, printline methods. So we do set at start time, retain default, and printing. Okay. Now I need to exit for this to take place, because what I've essentially said is retain anything that's in the current default setting, but also add printing to the startup time. So if I do exit, it kicks me out, go back in. All right, we're back in. Now, instead of doing the system.out print line, I can just type print. Hello. Hello. So, see, now you can remove those pesky system.out prefix. So let's recap. So we talked about using JShell as a means of testing our code, trying out different things in Java before we actually spend the time to actually type it into an editor or into our projects. We have different pieces within JShell, so we have the snippets or the different expressions and things we can type into the JShell command, variables, classes, imports, and such. We have the different types of commands like list, sets, environment that we can use within the JShell environment. For editing, we talked about the different keys you can use to jump around within the JShell editor. Also using the edit command to pop out to your default editor, either Notepad or the JShell editor. We also looked at importing and exporting code that you can pull into your editor, predefined scripts you may have defined, different types of feedback modules for the types of feedback you're going to get from the JShell commands. If you want to just echo, or if you don't even want anything to come back, you can turn it off. And you can actually create macros and scripts that you can run or trigger at runtime that will preload into your environment so you can have some scripts already ready to go so that you can simplify your work. At this point, does anyone have any questions?
So is the JShell, is it going to be, I mean a developer tool, is it going to be used as a JUnit testing tool, or, I mean, can you transfer your code from, let me say, from Spring and you paste it in here, or?
You can import your Java classes, but really this environment is not meant to be a unit test environment. It's meant to be kind of a developer's playground where I can go out and quickly hash out some code, flush out an idea, without having to deal with the pesky IDEs of having to compile, rerun, set my environments. I can just jump in here and go. I can just start typing. It's all real time. It's all pretty much compiled immediately and ready to go.
Okay.
Any other questions? Okay.
So the code you pretty much put in here, you can just transfer it straight to the IDE.
Yes,
without
you can export it to a file, or you can do the list and copy and paste it and put it into your IDE.
Okay, what about the other way around?
Same way, you can copy it from the IDE and paste it in. I was actually, during the demo, when the hypotenuse method broke, I went out and I copied it from my editor, and I just pasted it in, which is essentially what you would do. Any other questions? Oh, if that's it, thank you all for coming. If you have any questions, comments, or requests for assistance, please feel free to reach out to us at info@developerner.com or contact us on the site or just drop a message on our blog. Thanks. Have a great day.